quit on you. You stop sending them the one signal that builds them. After age 50, your body raises the price of muscle growth, and most people keep paying the old rate. A 2016 study at McMaster University found older adults need nearly double the protein stimulus to trigger the same growth a 25-year-old gets for free. Miss that threshold, and your muscle simply ignores the effort. Today, you'll learn how to send the signal again. Here's what almost everyone believes. Muscle loss after 50 is inevitable. A slow, sad slide you can soften but never stop. Your doctor implies it, your mirror confirms it, and the numbers seem to agree. After age 30, the average adult loses 3 to 5% of muscle mass per decade, and after 60, that rate can climb to 10%. But that belief is wrong in a specific, important way. The loss is real. The inevitability is not. Because the studies measuring that decline were measuring sedentary people who stopped asking their muscles to do anything difficult. When researchers looked at older adults who kept training, the picture changed completely. In a 2011 study published in the Physician and Sports Medicine, scientists scanned the thigh muscles of competitive athletes aged 40 to 81. The 70-year-old triathletes had nearly the same muscle mass and quality as the 40-year-olds. The decline wasn't written into their cells, it was written into their habits. So the muscle isn't broken. The machinery still works. Something is interrupting the signal that tells the machinery to run. And here's the part that should make you sit up. That interruption has a name. Scientists call it anabolic resistance. It's not a disease, it's a volume knob. And somewhere after 50, your body turns it down. The good news is that a knob can be turned back up. But to do that, you have to understand what the signal actually is, where it comes from, and why your body decided to stop listening. That answer involves something most people never learned. Muscle growth isn't really about muscle at all. It starts in your nerves. Let me show you the machine first, because once you see it, everything else makes sense. Inside your muscle, there's a chemical switch called mTOR. Think of it as the foreman on a construction site. When the foreman gets the right signal, he shouts, "Build," and your cells start assembling new muscle protein. When he's quiet, construction stops. Repair slows, the site goes dark. For a young person, that foreman is twitchy. He'll start building at the smallest nudge, a light meal, a short walk, a few push-ups. The threshold to wake him up is low. But here's what changes with age. After 50, that foreman gets harder of hearing. The same nudge that used to wake him now gets ignored. You eat the chicken, you do the exercise, and the foreman just sits there. This is anabolic resistance, and it's been measured precisely. In that 2016 work from Stuart Phillips' lab at McMaster University, researchers found that a younger adult triggers maximum muscle building from roughly 20 grams of high-quality protein in a meal. An older adult needs around 40 grams to hit the same response, double the input for the same output. Your body raised the price, and nobody handed you the new menu. But protein is only half the trigger. The other half is mechanical, and it's the part your doctor almost never mentions. Your muscle fibers come in two main types. Type 1 are your endurance fibers, slow, steady, built for walking and standing. Type 2 are your power fibers, fast, explosive, built for lifting something heavy or catching yourself when you trip. Here's the cruel detail. Aging doesn't attack both equally. It comes for your type 2 fibers first. A 2006 study in the American Journal of Physiology found that the satellite cells, the repair crew specific to those power fibers, declines sharply with age, while the repair crew for endurance fibers stays relatively intact. Read that carefully, because it explains something you felt. Your stamina holds up reasonably well. You can still walk for an hour, but your power vanishes. Getting up from a low chair feels harder. Catching yourself after a stumble feels slower. That's not general weakness. That's the targeted loss of your type 2 fibers, and they only respond to one thing: effort. Not gentle movement, not a casual stroll. Type 2 fibers are recruited last, only when the easier fibers can't finish the job. Your nervous system pulls them in as a reserve. So when you only do light activity, you never call on them at all. They sit unused, and in your body, unused means unwanted. The body is ruthlessly economical. It dismantles what you don't ask it to keep. So picture what's actually happening to most people after 50. They eat less protein than they need to wake the foreman, and they move too gently to ever recruit their power fibers. Two signals, both switched off at the exact age the body needs them most. This is why staying active isn't enough. Gardening, walking, light chores. They keep you functional, but they don't speak the language your power fibers understand. The research is still evolving on the exact thresholds, but the direction is clear. Intensity matters more than duration once you're past 50. But this is only half the story, because even if you fix the protein and add the effort, there's a third gatekeeper, and it sits not in your muscle, but in the wiring that controls it. What happens at that junction is more disturbing than the muscle loss itself. Here's where most explanations of muscle loss go wrong. They treat your muscle like a balloon. Pump in protein and exercise, watch it inflate. But your muscle isn't a balloon. It's an instrument, and it only plays when a nerve tells it to. Every muscle fiber you own is controlled by a single nerve cell, a motor neuron, reaching down from your spinal cord. The point where that nerve meets the muscle is called the neuromuscular junction. Think of it as a spark plug. The nerve sends a chemical spark across a tiny gap. The muscle fires, and you move. No spark, no movement. The fiber might be perfectly healthy, but without its nerve, it's a piano with no one at the keys. Now here's the brutal part of aging. You don't just lose muscle, you lose motor neurons. A landmark study published in the Journal of Physiology in 2016 found that by around age 71, healthy older adults have roughly 40% fewer motor units in their leg muscles than young adults. 40%, nearly half the wiring, gone. When a motor neuron dies, every muscle fiber it controlled is suddenly orphaned, cut off. No spark, no signal, no reason to exist. And an orphaned fiber begins to wither within weeks. This is denervation, and it's one of the deepest drivers of the muscle loss you see in the mirror. Your body isn't just shrinking the muscle, it's losing the ability to switch it on. If you've ever felt that your strength dropped faster than your size, that you look roughly the same, but you simply can't do what you used to, this is what's happening inside you. You haven't lost as much muscle as you think. You've lost access to it. But your body does fight back, and what it does next is remarkable. When a fiber gets orphaned, a nearby surviving neuron can reach out and adopt it. It sprouts a new branch, connects to the abandoned fiber, and brings it back online. Scientists call this reinnervation. It's your nervous system performing emergency rewiring to save what it can. Some researchers describe the aging muscle as a workforce being managed by fewer and fewer supervisors, each one stretched to cover more workers than they should. And here's the question that changes everything. What decides whether your surviving neurons keep reaching out or give up and let the fibers die? The answer, based on the current research, is demand. A neuron that's regularly challenged stays active and keeps sprouting. A neuron that's never asked to fire hard goes quiet and stops rescuing. Use drives the rewiring. Disuse accelerates the collapse. This is why, depending on who you ask, some scientists now argue the nervous system, not the muscle, is the real battleground of aging strength. If this is making sense, and you want the part that matters most, the exact protocol that reactivates this signal and how to do it safely after 50, subscribe now. That section is coming in just a few minutes, and it's the difference between knowing the problem and actually solving it. Because here's the truth that ties block 1 and block 2 together. Protein wakes the foreman. Effort recruits the power fibers. But neither works if the wiring is shutting down from neglect. All three signals run on the same currency: demand. And none of this fully makes sense until you understand what your nervous system is doing every time you load it hard enough to matter. What almost nobody talks about is this. The signal that builds your muscle and the signal that saves your nerves are the same signal, and it has a threshold you can actually cross. Your nervous system recruits muscle fibers in a strict order. Scientists call it the size principle. Small, weak fibers first. Big, powerful fibers last. Your brain is lazy in the most efficient way possible. It only calls in the heavy crew when the light crew can't get the job done. Pick up a coffee cup and you use a sliver of your fibers. The rest stay asleep. This is the most important thing in the entire script, so stay with me. To recruit your type 2 power fibers, the ones that vanish first, the ones tied to the neurons that die first, you have to give your body a reason. You have to make the light crew fail. That means either real effort against real resistance or moving with genuine speed and intent. There is no gentle path to your power fibers. They live behind a door marked hard, and there is no other entrance. 40% of your motor units, gone by 71. Most people spend those same decades never once asking the survivors to work hard. The wiring didn't fail you, it was never called. Here's the part that turns the whole story upside down. When you finally do cross that threshold, when you lift something heavy or move something with force, you're not just stressing muscle. You're sending a survival signal up the nerve. Researchers studying the neuromuscular junction have found that high-intensity contraction triggers the release of growth factors that help maintain and repair that junction, the spark plug itself. In other words, hard effort doesn't just build muscle. It tells your motor neurons to stay alive and keep doing their job. This is why intensity beats duration after 50, and it's not close. A 2019 review in Frontiers in Physiology found that even lifelong endurance athletes, people who exercised constantly for decades, still lost motor units at roughly the normal rate, because endurance work never crosses the recruitment threshold for the power fibers. Running for hours does not save the fast wiring, only force does. Let that reframe everything you've been told. The man who walks 5 miles a day but never lifts anything heavy is protecting his heart while his power fibers quietly disconnect. The woman who does light aerobics 3 times a week feels active, but her type 2 fibers and their neurons are starving for a signal they never receive. Activity is not the same as the signal. Comfortable is not the same as effective. I guess most of you have felt this without naming it. The slow realization that you're busy and moving, yet somehow weaker each year. That gap between activity and strength is the gap between using your small fibers and waking your large ones. So the question becomes the only question that matters. If your body has this built-in signal, one that grows muscle and saves nerves at the same time, how do you send it deliberately, safely, at any age? That's not vague advice. There's a specific protocol, backed by research and used by clinicians who treat aging muscle every day. Here's exactly how to do it. 4 steps. Each one targets a specific signal we've discussed. Follow them in order. Step 1. Cross the protein threshold at every main meal. Remember the foreman who's gone hard of hearing. You have to shout. For most adults over 50, that means roughly 30 to 40 grams of high-quality protein per meal, not spread thin across the day. A young person can trickle protein in. You cannot. Aim for that target at breakfast, lunch, and dinner. Why it works. Hitting the higher dose overcomes anabolic resistance and pushes leucine, the specific amino acid that flips the mTOR switch, past the level your aging muscle now requires. Breakfast matters most because most people undereat protein in the morning and miss the entire first building window of the day. Step 2. Lift something heavy enough that the last few repetitions are genuinely hard. This is non-negotiable, and it's where your power fibers live. 2 to 3 sessions per week, targeting the major muscle groups: legs, back, chest. Choose a resistance where you can do roughly 8 to 12 repetitions, and the final 2 feel like real work. That difficulty is the recruitment signal. If the last rep is easy, your power fibers stayed asleep and the session barely counted. Why it works. Only effort near your limit forces your nervous system to call in the type 2 fibers and fire the neurons that protect them. Step 3. Add speed to one movement. Not heavy, fast. Pick a safe exercise, like standing up from a chair, and do it as explosively as you can. Then sit slowly. 5 to 10 repetitions. This is called power training, and a growing body of research shows it protects the fast wiring even better than slow, heavy lifting for some older adults. Why it works. Speed of intent recruits the highest threshold fibers almost instantly, sending that survival signal straight up the nerve. Step 4. Never train the same muscle 2 days running. Your repair crew, those satellite cells, needs 48 hours to rebuild. The signal is sent during the effort, but the muscle is built during the recovery. Skip the recovery, and you're sending the order without ever letting the construction finish. If even one of these steps was new to you, hit the like button. It genuinely tells the algorithm to show this to more people over 50 who've been told muscle loss is just their fate. That one tap helps someone's parents stay independent. It costs you nothing. Here's the encouraging part, and it's backed by hard data. Dr. Maria Fiataroni ran a now famous study at Tufts University, published in 1990, on frail nursing home residents, people with an average age of 90. After just 8 weeks of high-intensity strength training, their muscle strength increased by an average of 174%, and several traded their walkers for canes. 90 years old, 8 weeks. The signal worked. That study buried the idea that it's ever too late. The machinery never stopped working. It was only ever waiting for the right instruction. Your muscle doesn't check your age before it responds. It checks your effort. Send the signal correctly, and a body in its 70s, 80s, even 90s will answer. Because the biology of building muscle doesn't expire. It just goes unused. Step back and look at what this really means. For most of your life, your body built muscle in the background, asking nothing of you. After 50, it starts asking. It raises the price and waits to see if you'll pay it. And most people, never told the rules changed, simply stop showing up and then mistake their silence for the body's failure. But it was never failure. It was a conversation, and one side went quiet. I want to hear from you. Drop a comment below. What's the one thing in this video you wish someone had told you 10 years ago? I read them, and your answer might be exactly what another viewer needs to see to start. And here's something worth testing right now. Can you stand up from a chair without using your hands, 5 times in a row, smoothly? Tell me in the comments whether you can. It's one of the simplest measures of type 2 fiber health there is, and it tells you more about your aging than almost any number your doctor will give you. Everything we covered comes down to a single idea. Your muscles are not running down like a battery. They are waiting for a signal, one you stopped sending without realizing it, and one you can start sending again today, at any age, with effort that's heavy, fast, and fed. Remember this, because it's the whole truth in one line. Muscle doesn't fade with age, it fades with silence. Share this with someone who's been told they're just getting old, because they've been lied to, and this is the correction. And if you haven't subscribed yet, you should. What's coming next is something I've been researching for months, and it changes how you think about strength entirely. Your body is still listening. The only question left is whether you'll speak.